to talk to you about the discriminant. And the discriminant is a number that when you're using the quadratic formula to find the solutions to a quadratic function, it's the number that's underneath the square root symbol. Not the square root symbol, not the result of the square root, but just the number that's underneath the square root. And that's called the discriminant. And looking at the discriminant, you can determine how many solutions there are to the quadratic function. So if the number that's under the square root is less than 0, that means that there's no real solutions. It's actually going to be, the reason is because you can't take the square root of a negative number. So they're complex numbers, but you haven't learned about that yet. So there's no real solutions. It just means that the graph is going to look something like this, like the parabola is not touching the x-axis. If you get x, or the discriminant is equal to 0, this means you're finding the square root of 0, which is 0. Then there is one vertex. There's only one solution. So the vertex is the x-intercept, the one single solution. And then if you get that the discriminant is greater than 0, then this means that there's two solutions. So it's like if you're looking at a coordinate plane like this, and I know that didn't touch exactly, but it crosses at two places, so there's two solutions. So I'm going to work through these examples, and I'm going to show you how we can find the discriminant. So here, if I start with this example, A is equal to -1, B is equal to 6, and C is equal to -5. When I plug into the quadratic formula, it's going to be -6 plus or minus the square root of 6 squared minus 4 times -1 times -5, and all of this is divisible by 2a. So I'm going to keep simplifying it. I get that -6 plus or minus, and I'm sorry, this is all equal to x. I probably should have said that. Plus or minus the square root of 36. -4 times -1 is +4. +4 times -5 is -20. And then all of this is divisible by 2 times -1. And that's equal to x. So we end up with -6 plus or minus the square root of 16 divided by -2. So at this point, we can tell that the discriminant is 16, which means because it's greater than 0, this means that there are two real solutions. So just to take this a step further so you can see what I'm talking about, we have -6 plus or minus 4 divided by -2. There's two things that we can come up with here. We can have -6 plus 4 divided by -2, or we can have -6 minus 4 divided by -2. Here we get -6 plus 4 is -2, divided by -2 is 1, and here we get -10 over -2, which is +5. So we do get two solutions. We get that x is 1 and that x is equal to 5. Just like it said, the discriminant, because it was a positive number, it's greater than 0, that there would be two solutions, and there were. All right, so let's do another example. Here, A is equal to 3, B is equal to -6, and C is equal to 3. So when I plug this into the formula, I'm going to have -6 plus or minus the square root of -6 squared minus 4 times 3 times 3. And this is divisible by 2 times 3, and all of this is equal to x. So -6 is +6 plus or minus 36. Let's see, -4 times 3 is -12 times 3 is -36. And all of this is divisible by 6. So we end up with 6 plus or minus the square root of 0 divided by 6. Now, again, I can tell at this point, because the discriminant is 0, that there is exactly one solution. And so just to show you, all of this is 0. So we have 6 plus or minus 0 over 6. Well, there's nothing to plus or minus. It's just 6 over 6, which is 1. So x is equal to 1. So there's one solution, just like the discriminant said there would be. And the last example, let's say A is equal to 2, B is also equal to 2, and C is equal to 3. So when I plug in the quadratic formula, I get -2 plus or minus the square root of 2 squared minus 4 times 2 times 3. And that's all divided by 2a. So 2 times 2, that's all equal to x. So -2 plus or minus the square root of 2 squared is 4. 4 times 2, or -4 times 2 is -8, times 3 is -24. And all of this is divisible by 4. And to take it a step further, we end up with negative 2 plus or minus the square root of negative 20 divided by 4. Now, I know now that because I'm taking the square root of a negative number, which is an imaginary number we haven't had yet, that there are no real solutions. They're actually called complex solutions or complex numbers. But for what we are doing at this point, there are no real numbers. And again, this means that it's going to be kind of hanging out something like this, okay, that it's not touching the x-axis.